Hello everyone, how are you? I hope you guys are doing well. My name is Uday Bhan. Welcome to my YouTube channel AI with Uday, where I upload videos related to machine learning and AI. In today's video, we will create a machine learning model where we will try to predict the gender of a particular voice clip, whether it is from a male or a female. So let's get started. Here is my Jupyter notebook file where I have written the code, and I will go through line by line. And first of all, I will give you a project overview. The aim of this project is to build a machine learning model that predicts the gender of a speaker based on the voice sample. For this particular project, we are using a dataset which has audio features extracted from voice recordings and target variables as either this audio recordings is from a male or female. I believe that this is a unique project because it combines audio signal processing with supervised machine learning classification models, and this whole project combines the data processing, outlier removal, feature scaling, and hyperparameter tuning as well. So it will be a from scratch to end project for machine learning beginners as well as intermediates. So the concept which I have covered in this particular project is like the EDA, outlier detection, then feature scaling, then model training, and hyperparameter tuning. Here I have provided the dataset link. You can download the dataset from here. Without wasting any time, let's get started to the coding. First, I have imported the libraries, and the libraries you can see NumPy, Pandas, Matplotlib, Seaborn. These are the basic libraries. Then machine learning tools, then some optional libraries as well. I will explain each library as we use them. So I will first run this and see, I have got no errors because I have already installed all these libraries. But if you are doing it for the first time, then you need to install all these libraries. Next, I will load the data, and you can see I have written the code pd.read.csv, and I have given the path of dataset. Since my dataset is in the same directory as my notebook file, so I will give only the relative path. So you can see here I have given the relative path here voice.csv, and I have then basically printed the top 5 uh, rows in the dataset. So you can see there are so many features, and then we have this label male and female. The next is the initial data exploration, and in that I will show you what is the dataset shape currently. And you can see dataset is having 3168 rows and total 21 columns, which includes the label features as well. Now I will show you the info about this dataset. So I will run df.info, and as you can see I have total 21 features from mean, frequency to label, and each dataset is having exactly equal count, that is 3168, and there is no null values. And the data type of all the features is float 64 except the label one, so it is a object variable. Next we will check what are the missing values. So I will just run df.isNull.sum, and as you can see there is no null values. Next I will check if there is any duplicate values or not. So I will write df.duplicated.sum. This is saying like you have two duplicate values. So I will try to drop those duplicates, and I will keep the unique ones. So I will write this df.drop duplicates and keep is equal last. The next is convert this label feature to a numeric feature. The label is currently object, so we will write this code df label.map male to 0 and female to 1, and we will again assign the updated values to the label feature. This will replace all the male to 0 and all the female to 1, and it has been successfully run. Now the next is check for extreme values. That's why I have written this df.describe.transpose, and if I run, you can see it has printed all the staticals important features. As you can see, we have the count of all the variables, mean, standard deviation, minimum value of those variables, then 25 percentile of the variables values, then 50 percentile, then 75 percentile, and then max values. But there are some variables which are not there in similar scale. As you can see here, this cut variable. So the 75 percentile is 13, but the max value is 1309, that is 1309. Now what we will do, we will just draw the graph of outliers features. In the graph, I will draw the box plot, run this for loop, and it will print all the different uh, features box plot one by one. Box plot of the skew is here, and you can see the most of the values are in between 0 to 5, but there are so many outliers which are having values from 5 to 35. The same for the cart. The maximum values is 1300 and something, but the most of the values are basically having 0 to 10 as the range. Then there is box plot for the mean dome. This is also having outliers when the values are going above 2. And then for the max dome, this is having outliers when values are going around 15 to 20. Then same for this DF range as well. Next is outlier removal using IQR method. So what we will do, we will remove the outliers, and we will keep a filtered data frame of our voice data. So first we will copy all the data which is there in the DF, which is our voice data set, and we will name it DF underscore filtered, and then we will find out basically which are the outliers. So we will iterate through outlier features list, which I have already declared here, and I will use IQR method to remove the outliers. So after this particular lines of code is successfully run, then DF filtered basically will be having your new data set which will not be having any outlier. So I will just run the particular cell, and you will see what was the original shape of the data set and what is the shape after we remove the outlier. As you can see, the original shape was 3166 rows and 21 columns, but the filtered shape is 2717 rows and 21 columns. Now we will do the exploratory data analysis. I will first plot the graph of class distribution of each male and female. As you can see, there are almost equal number of male and female count in our data set. Next, I will draw the distribution of all the different features which is there in our data set. As you can see, for the first feature, which is mean frequency, so the data distribution for the female, which is in light yellow color, is like this. For the male, which is in purple color, is like this. So you can go through all the different features. The next is the correlation heat map. As you can see, this particular mean frequency is having very high correlation with this particular feature, which is centroid. So now we will print what are the different correlation coefficient with level feature. So I have already run this code. The level is having correlation with mean funcs as 0.84. This is maximum. Then the second is IQR. Then third is Q25. Then fourth is SPENT. Then fifth is SD, and sixth, seventh, eighth. There are so many, but top 5 are these. Now we will draw the pair plot of top correlated features. So I have run this code, and you can see the pair plot of all the different highly correlated features. Green one is for female and the orange color is for male. So you can see there are clearly two different groups for these two different gender. So all five top correlated features creating two separate groups for these two different gender in the pair plot. Next, we will see feature scaling and train test split. So for X, we will first drop the label, and for Y, we will just take the label, and then we will use standard scaler. We have X scaled, then we have splitting the data using train test split. This train test split we have already imported in the very first cell. Now I will run this code, and we'll move on to model training part. I will write this particular function, which is evaluate model. So for support vector classifier, we will train this particular model using xtrain and ytrain, and then we will call this evaluate model, and this function will evaluate the model and show us the accuracy and classification report along with the confusion matrix. Next is random forest. The same thing we have done here as well, and the third is logistic regression. So as soon as I run this particular code, so it will show me the accuracy, classification report, and confusion matrix for all three different classification model. So you can see the first one was support vector machine classifier, and the accuracy is 0.98. Then classification report is having this particular result, and the same thing we can see here in the confusion matrix as well. The next was random forest model. It is having accuracy 0.9834, and as you can see, it is having less accuracy compared to this SVM classifier. We will move on to the next one, which is logistic regression. So it is having 0.9834 as the accuracy along with the classification report results. This was basically the baseline for all three different models, but now we will go on to the hyperparameter tuning parts and then doing the cross validation on that. First, we will create a tune model function which will take model parameters grid and x, y as input, and this particular model basically uses GridSearchCV and then train the model, and then it will tell us what was the best parameters and what was the best cross validated accuracy of that particular tuned model, and it will return the best estimators. So first we will train for the SVM, and this is the support vector, the tune parameters, and then we have called this tune model which takes all the input features. First is the model itself, then tune parameters, then x train, then y train, and it will return the best estimators, so that will be saved into best underscore svm variable. And also we will call this evaluate model once again, and this time we will basically try to get the accuracy and the classification report of the best tuned model. So I have already run this particular cell, and you can see the best cross validated accuracy was 0.9784, but the tuned SVM results is showing the accuracy is 0.9871, and then we have the classification report and we have the confusion matrix as well. Similarly, we will tune this random forest model, and we have the tune parameters for the random forest. Remember, the tune parameters are different for the different machine learning models. So for the random forest, it will be having different tune parameters. Then we will call tune model function, and again we will call evaluate model. Now I will run this particular code, and you will see the code is running, and the tuning random forest is completed, and you can see the best cross validated accuracy is 0.9788, and this is the best parameters here, and this is the best cross validated accuracy. Then we have the tuned random forest result, and the accuracy is 0.9852. This has got increased, and then we have classification report and confusion matrix. And the next is hyperparameter tuning of logistic regression model. This is having tune parameters like this, and we will simply call the tune model and then evaluate model, and we'll see the result. I have run this code, and you can see this is the confusion matrix. Then we have some warnings as well. We will ignore these warnings and we'll come to the best parameters. So these are the best parameters combination. Then we have the cross validated accuracy. This is 0.9715. Then we have tune models accuracy and classification report as well. So the accuracy is 0.9834. So this way you can train the machine learning model and use the hyperparameter tuning on the baseline model. Next we will print the cross validation scores. So for that I have written a simple function print CV score. It takes models and x and y values as input features. We have called this cross value score. I would call this particular function for the different best hyperparameter tuned models which we have got received in the above cells. So for the support vector machine classifier we were having best SVM. For the random forest we were having best underscore RF. Then for the logistic regression we were having best underscore LR. So I will call this particular function and I will run this cell. Now you can see the cross validation accuracy for the support vector machine classifier is like this. This is 0.9555 plus minus 0.0277. Then for random forest it is 0.9643 plus minus 0.0179. And then in the last we were having the cross validation accuracy for logistic regression which is having 0.9665 plus minus 0.0168. You can decide which model is performing better using this cross validation accuracy. As we have come to the end, so we'll just show you what are the feature importance in this particular project. For feature importance I will consider the random forest tuned model, and we'll get the importance and the indices of those importance and as well as the features. And once we get all these things, we will plot the bar plot. As soon as I run this particular code, you will see a bar plot showing the most important features in descending order. So you can see the mean funcs feature was the most important, then IQR, then Q25, then SD, then SPENT, then SFM, then centroid, then mean frequency. All those the important features are there in the descending order. We have come to the end, so I will just summarize in my words, which is all the different machine learning model which we tried out all perform very well on this particular voice based gender classification problem. The main point was the outlier removal using IQR method, and then hyperparameter tuning using GridSearchCV. I hope this was helpful for you guys. Thank you.